Hello, we're going to take a look at your MT3 LT5 review affirmation right now. On this first question, is the rotational symmetry? Can you turn this shape at an angle other than 360 degrees? Because we know when you turn it 360 degrees, you get the same exact shape that will look exactly the same. And with this pointer, and there's nothing else that's the same, that answer is no. So this one does not have rotational symmetry. Let's take a look at another problem here. On this one, it's an equilateral triangle, and line C bisects each side it passes through, and line D passes through the vertex and bisects the sides, and we know P is the center. Well, let's talk about rotational symmetry. Since it's equilateral triangle, we take 360 divided by the order, which is 3, because there's 3 points where it's going to be exactly the same. So any multiple of 120 degrees is going to have rotational symmetry. So 120, 240, and 360 would be your rotational symmetry. If you reflect it across line C, point D ends up over here. There's not a point here, is there? So that is not the same, because symmetric means you have to put it onto itself. How about 180 degrees? Well, 180 degrees is not a multiple of 120, so that's not it. 360, yes, because you can always rotate it by 360. I think that's the one you didn't have on your affirmation. Reflected across D. Now that one we can reflect across D because it will match up. I think you had that one on your affirmation. Let's take a look at another problem here. We got this square. So if we reflect it across line B, everything matches up. So we have that one. How about a 270 rotation? Well, if we take a look here, let's take a look at the rotations. We take 360 divided by 4 because it's a square. So any multiple of 90. So 90, 180, 270, and of course 360. So yes, you can rotate it through 270 degrees. How about we reflect it across A? Well, the corners would match up, so that would also work. 180 rotation, that works. So in other words, it's all of them on this one. And this one, first of all, notice it's the regular polygon, the one on the left I'm talking about. So let's take a look. Yes, it has rotational symmetry because I can turn it so it matches onto itself. So I should say yes, I guess. Now let's find the angle. We'll take 360 and we'll divide it by 5 because there's 5 vertices or 5 points. So let's use our calculator for this one. So we take 360 divided by 5. That angle rotation is 72 degrees, which means we could have different rotations that are multiple of 72. Now, on the second one, with that point, we don't have rotational symmetry, do we? Kind of looks like a home plate or a house, doesn't it? So this one is no, because it doesn't match onto itself when you turn it. And then finally, we're supposed to draw all the lines of symmetry here. You correctly had the horizontal line, because if you draw that through, they match up. You can't have a vertical one because we've got this segment right here and there's nothing over here on the side. So there's no vertical one. The diagonal one, we got a problem there. It's a rectangle. If you draw it across the diagonal, they don't match up. You don't have this corner here either. So the only one you have is a horizontal on this one.